Hello, good morning. Welcome to JCE Connect. In the last class, we have finished with the properties, composition, and application of engineering materials. So, which is the now we'll be dealing with the next part of the module 4, that is the joining processes. So, where are these joining processes are done? So, these are used to join the two metals together. In this, the various processes are used to join the metals together. Depending on the It depends on the material and the thickness of the parts to be joined, and what is the degree of permanency of the two joints of the material. So, the different processes which we are going to study in this are the soldering, brazing, and welding. Soldering. So first we will be dealing with the soldering part. So you might have seen the soldering which is done in the electric circuit boards. If you go to any electrical shop, or if you go to any electrical repair shops or service centers, or when you are going for mobile service centers, you can see that he is having some kind of a rod which is known as iron, solder iron, and he is trying to put a filler metal, and it is filling some part of the PCB or a board. You might have even seen that in the old TVs which had some PCBs and all, they are going for the soldering of the parts in that. So this is commonly seen soldering in electrical shops or electrical service centers. So soldering is a method of joining two thin metal pieces using a dissimilar metal or an alloy by the application of heat. So you are joining two thin metal pieces using a dissimilar metal or an alloy which is known as a metal filler metal or solder by the application of heat. So the alloy which is used, which is nothing but a lead and tin, called as soft solder, which is used in varying proportions for sheet metal work, plumbing work, and electrical junctions. The temperature of the soft solder will be between 150 to 350 degree Celsius. So soft solder are nothing but lead and tin. This soft solder is nothing but a dissimilar metal which is used to join two thin metal pieces. The temperature required for soft solder is 150 to 350 degree Celsius. To prevent oxidation, a suitable flux such as zinc chloride is used in soldering. Flux is used to remove the oxidation from the surface on which you want to solder. A soldering iron is used to apply the heat produced from the electrical source. An alloy of copper, tin, and silver, known as hard solder, is used for stronger joints. If you want a stronger joint, we are using copper, tin, and silver as an solder. The soldering temperature of hard solders range from 600 to 900 degrees Celsius. So it means that for if it is a soft solder, we want the temperature to be 150 to 350 degrees Celsius to melt that alloy of lead and tin or the solder. If we want a hard solder, we are using an alloy of copper, tin, and silver, which is at giving a stronger joint for us to join the two metal pieces, and which requires a temperature of 600 to 900 degree Celsius, which is provided by the soldering iron. So now we'll be studying the different methods of soldering. The first one is the soldering iron method. So this is the most common one which is used in most of the electrical service centers. So it is usually consists of a this is nothing but a soldering iron rod. This is a stand on which it is placed. Okay, this is connected to an electrical source, which is using which we are heating this tip. Okay, so this tip is heated up, and we are providing a solder where we are melting the soldering point and the solder and after connecting it with the solder iron. Okay, so this is the flux which is used to deoxidize or the removal of oxidation and to clean the surface of the board on which you want to do the soldering. This is the filler metal or lead, or also known as, which is made up of lead, which is also known as solder. You can see some different steps over here which is used. First, the iron soldering iron and the solder is brought in contact. The soldering iron is being heated up, and after that, when they heated up, it is brought in contact with the PC or the board or which metal you want to join, and the solder at a same exact position. And after that, when it brought into the contact with the solder, it will start melting at that point, and because of which there is a formation of melted melting solder which is forming a dot on that, and it is getting solidified because of the sudden change in temperature, and with that there is a solder junction created or a solder point created. Okay, you can see that remove the solder but keep the iron still in the joint. So when we keep it as it is, what happens is when we remove the solder, it will keep the solder at that point where you want to create a joint, and at the end we are removing both the iron and the solder. So this is the way they are joining the electronic components on a PCB, that is printed circuit boards. So we'll go with the steps again. So first we are cleaning the joining surface. What is the method of this soldering iron method is, first we are cleaning the surface. What we are doing, how to clean it, we are first the joining surfaces are cleaned mechanically to make them free from dust, oils and scales, etc. Next is we are applying the flux which is made up of rosin or borax. This cleans the surface chemically and helps the solder in making a bond. Next is tining of the surfaces to be soldered. Before soldering operation, the iron must be tined, which means that we are removing a thin film of oxide from the tip of the iron soldering machine, and which is used to be heated, and it becomes difficult to solder. If that oxide is not removed, it doesn't get heated up, and it is very hard to remove that. It is very hard to melt or difficult to solder. Okay, the next is the heating part. The soldering iron is then heated, and the flowing molten filler fills. Flowing molten filler is nothing but the solder which fills the joint interface. So the solder and the iron soldering machine is brought in contact with each other. So because of the heat created by the soldering iron is used to heat the filler metal which is to be filled in the gap, and that is creating a molten metal in that, and that is creating a joint interface between them. And after the it is melted, it is allowed to cool, which makes, after allowing it to cool, it will get solidified and makes this a joint. So the next is final cleanup. After completing the soldering, the joints are formed. We are cleaning it with a steel wool or a solvent to remove leftover flux. After this, the clean the soldering iron using a damp sponge. So whatever the things which are required for the soldering processes are the filler metal. It may be made up of lead. This is borax, or which is a flux, and this is a iron, soldering iron, and this is the stand. So if these things are there, we can solder a printed board or any two different metals by using a filler material. So first one, another next type of method is torch soldering. So in this type of soldering, we are using a gaseous form of oxyacetylate gas torch, which is being used to melt the area which you have to join. So that has been passed over that, and we are connecting it with we are applying the filler metal to it. So So that is allowing it to melt at that point, because the surface is already heated by this oxyacetylene torch, oxyacetylene torch, and this is heating it. So this is kind of blow torch which is used. You might have seen this in somewhere on the in electrical shops or automobile industries or any of the metal joining industries. So in this type of soldering, the required heat in order to heat the joint is supplied by the flame of an oxyacetylene gas torch. So whatever heat is required in the previous method, we are using a soldering iron method. So we are using a soldering iron. So the tip of the soldering iron is being heated by the electrical supply. But here we are heating the surface by using the oxyacetylene torch, which is a mixture of air and oxyacetylene fluid or gas. So the blowtorch consists of a mixing chamber where acetylene and oxygen are mixed in a required proportion, and the flame is directed towards the workpiece. So by mixing it, we are passing the air and fuel mixture here, and that is burning the creating a torch that is burning it. Okay. So the workpieces are then heated to the required temperature, and the solder is fed into the joint area where due to heat it melts and flows into the gap in between the two work pieces. Upon cooling, the joint is formed, and the torch soldering is mostly used in plumbing field or soldering copper tubing to copper fitting. So only the gas torch is put on the this component, it is being heated up, and the filler metal is passed to it, and wherever the joint is needed, it is filling the joint by filler metal. So it is first heated with the oxyacetylene gas torch. The next one is wave soldering, in which it's a large scale soldering process in which the electric components are soldered to a printed circuit board form an, to form an electronic assembly. So in this, what is happening is the printed circuit board is made to flow over the wave of the solder reservoir, and which is creating a the molten solder is pumped out of the narrow slot, thus creating some waves. There is a narrow slot which is present over here. It is creating some waves in this, and it is brought in contact with this PCB. So the printed circuit board is moved over these waves, and at the from the bottom of the it comes in contact with this wave, and it forms the solder, and and the solder whatever is there, it will stick to this printed circuit board because of surface tension, and it is heated up. So the soldering is done in this way also by wave soldering method. Okay. So next is the advantages of soldering. It is the low cost and easy to use. It's easy to repair and to do rework. The soldering joints are not so much strong, so that we can easily repair. In normally TVs and all, it has been for service, we are using it for servicing, so it can be done in a frequent manner whenever there is a repair work. And the soldered joint can also last for many years. Low energy is required to solder, and an experienced person can exercise a high degree of control over the soldering process. The disadvantages are it is having very limited strength as we are using low melting alloys. The same heat is applied for the whole assembly. It can be detrimental to components in the assembly that are heat sensitive. So what if beside that, if there is any material or if there is component in the assembly, it will create a it will be harmful for the or it will be detrimental to the components which are beside the component where you are soldering. So they may be heat sensitive, or it may create a damage to the other parts of the assembly. It is not easy to disconnect soldered connections. Removal of the solder may cause physical and electrical damage which cannot be repaired. The heat of the soldering iron or flame of the torch can cause damage to the adjacent components. As I have said, it may cause a damage to the components which are adjacent to that part, and it may lead to further complications of the part. The solder which is there or filler material, it contains lead which is toxic in nature, and when we are heating it, it is leaving some kind of flames or gases which can cause negative effect on our health and the environment. Okay, so this is about soldering, and we'll discuss about brazing and welding in the next class. Thank you.